We continue with the robotics trends. And now we have a presentation on smart robots of the future. Our next speaker is Li Jizin. The first humanoid robot was created in 1970 in Asia. It could communicate in Japanese, it could see and hear. What can such robots do now? Let's hear more right now from Professor Li Jizin. A big round of applause.
Профессор Харбинского института технологий.
Professor of Carbon Technology Institute, Li Jizin. AI operational system for smart humanoid robots.
Hello, everyone. Good afternoon. I'm the last speaker, and thank you for your patience. I'm a very great honor to share some our work with you. It is about the development trend of the humanoid robot in operating system. I'm Zhi Junli. I'm a professor of Harbin Institute of Technology. Maybe Harbin is very familiar for the Russian person. And I'm also a chairman of the Shanghai Jushi Intelligent Technology Company. So I'm a researcher and also an industrial man. Okay, the topic of this talk includes 3 parts. The first one is motivation. Why we just do such study? Research studies the operating system for the humanoid robot. The second one, what should I do to innovate? Because the humanoid robotic is a very new one. It is not just every the devices we just used before, such as cell phone, a PC, that's all. So there is an innovation. What should I do? The third one, the last one is application. How it look like? Just we have done for these researches. So the first one is motivation. As we have, we all the computer science. Maybe there are a lot of majors, but I am a computer science. For computer science, what the operating system is? So we know that we all know that the Windows, just like this one, and we know the left one is a computer. It's a very old computer. It's hard to operate, but they use some expert. But we know that we use Windows, we can just make these devices can be utilized by everyone all over the world. What's the main part of this? What's the key of this change? We know that it is operating system. It is GUI, graphic user interface. That means there are a lot of elements in the screen. You can see it, watch it, you can understand what that means, and you can just click it or just make that work. So it is GUI, make the devices, make the PC computers go to everyone's world. The second big breakthrough is the mobile phone operating system, such as Android, iOS. And we know that if we look like this finger, it is a PC top and it is a old cell phone with a keyboard. But it is not very good to use. But if we use the Android, we can use our finger to touch the screen. So everybody all over the world, no matter what this old or young, or just our children, they all can use it. So it is a very big breakthrough to make a good thing happen. So now we are in the area of the new world, humanoid robot. It is maybe the maybe it is the most excited devices that the human can make. So it is humanoid devices, humanoid robot. It is made by a company of my student. So I and my student cooperated to make this thing happen. He make this robot, and I make the operating system to install to make that very good to use. So there are very big questions for these things. What should this question mark? What is the operating system to humanoid robot? If it is Windows, Android, iOS, no. So if we use just this operating system, we cannot make the human robot as a human. We cannot transform the robot as a robot into a human. So we should make this picture come true, but we cannot if we don't design a new operating system. So this is the motivation of our research. But what is the challenge of this operating system? You can just look at this figure. And this is a real robot. It worked in the real industry site, just like that. This is in a company in the Suzhou province, just a city aside from the Shanghai. Maybe you know the Shanghai. So if we use this, if we look at this industrial site, the robot will do something that human can do it. You can see that this is just a coil. A coil, the robot need to take this coil into and weigh his weight. And if it is maybe in the 100, maybe that correct. That okay. That if it is with the qualified, that this coil will be put this side. If it is not qualified, it will be put another side. So this is the robotic need to work. But we know that if we use the robotic, if we use the operating system, there is a robotic operating system for the robot. It names robotic operating system (ROS). Maybe you all know that operating system, that software. But if we use this this ROS, that what they will work. They just need to understand. They need to understand the workflow of this work, of this job, and decompose the steps of these workflows, and do some program to make some program to do the things, and they need to build maps and build maps based on the workflows and setting movement trajectory on the maps. That's all. But if you know that it is a very solid diagram, not flexible. But if you look at these scenarios, you can see that there are a lot of dynamic scenes, dynamic situations. Maybe I have given you some examples. Environmental characteristics, table distance, because this is a real platform in the industry site. This platform may be large or small. You cannot let all the platform just as the same thing. You cannot, because it is a real world. There are a lot of the differences. So if the table distance is just far, how did you do that? Just you need to redesign the whole workflow and make a programming. But if the platform is just small and you go near to the platform, what should you do? You need to redesign the whole platform, the whole workflow, and do some programming from scratch. It is not very good, and it will be lead a very bad result. There are a lot of the need for customization. It is very difficult to make profit, to get some money, because there are a lot of work to do customization. So this is the current state of the robot. You cannot make profit. There are a lot of the things we all know in these days. We all discuss something about large language model, large model, and it will be work in the robotics field. It's okay. There are this is another design for the robot, large and small design, large and small brain. That means we have get a large model, a lot of the small models, and they will cooperate to get something done. This is just a picture come from the Google. Maybe you just have said it. But in my view, it won't work in this field, because if there are also a lot of the change in the real scenarios. In this example, there are unexpected unstable electrical conditions, such as in this is a kitchen. You open the lamp, it is light. You can just do it. Use RGB, maybe some CV, computer vision, and algorithm. That's all. But if you close the map, because you are the kitchen, the lamp cannot always be open. So what should they do? You cannot let a company, a big company, to train all the situations, all the models for all situations to do things. So it is also not practical for real world application. So this is the motivation of our work, the work of my team, my research group. So this is the overview of the current state of the robot operating system. You can see that this is a mechanical system, and this is computing hardware, operating system, and the integrated system, robotic ecosystem, autonomous evolution, and this is final form. And in my opinion, we have done these things. Mechanical system. Just maybe you see the humanoid robot in this stage, but there is no good operating system. There is no robot ecosystem at all. So this is our state. And if we get to the final form of the robot, we need to do a lot of work to go through this line. So this is motivation of our research group. So the second was innovation. What should I do to make the robot can work in the real world situations without just the train again, just the program again and again? This is the object of my research team, and this is my dream. So what is innovation? This is a zero-layer architecture of the operating system for humanoid robot. So I will give you some details of this architecture. You can see that it is the whole picture of this architecture. We have the 1, 2, 3, 4, 5, 6, 7, 8. We can 8 the component. It is big parts of the our operating system. And all of these components is new. Let me give some example, some details of these components. This one, intent interaction. What means intent? In the past time, for Android, for the Windows, we just do some programming to make things happen, to make our computer work. But what intent? What the human do in the real world? I will give some example. What should I do if I just call to maybe my wife in Chinese? I will call it, and what should I do to do this job, do this task? I need to just pick up my phone and call the number. And that is the programming. That is the procedure, the fixed procedure. And we can just program it. But if we know that I come here maybe yesterday, just yesterday, and from the Beijing to Russian, and this phone cannot work because I haven't SIM card. So I need to another phone. I need to another phone to do these things. The program cannot deal with such change because the program just know that this phone can call, but they knew that we have a different situation. We have a new country that we need to another phone to do these things. Human can do it. The program cannot do it. This is the intent. What means intent? Intent means what is the object of our task. We just call my wife. So this is intent. What should I do to do? What should I do to just make the things, make the object can be satisfied, make the things happen? And this is the intent interaction. This is intent driven. And we need to flex task. We need to combine the ability of these two phones and can get the object to satisfy. So this is human do something work. It is not the computer do things work. So we need a new design for operating system to do these tasks. This is the new design of our architecture. So that you mean maybe you can just maybe you just wonder if we just make all things, all cases, we could just consider all cases, and we just program case by case. It is not, it cannot work because there are a lot of the detailed cases. Because you know how many phones that the people can take. I am very wise as a third phone. What should the system can do if there are somebody no phone, one phones, two phones, and three phones, maybe a lot of things. So this is the new design of our operating system. Operating system is our architecture. The intent contention, the intent interaction, the flexible tasks, and the autonomous evolution. So the operating system can evolve it by itself. Maybe I will give another example. At the cell phone, I have no SIM card. The cell phone cannot work, but I have the internet. The new app can work. It is WeChat. But I didn't program these situations. So the robot can learn something, how to use the WeChat. So it will be learn something, learn some new skills, and do things work. So it is autonomous evolution. So that means that, in conclusion, that means that this new operating system must have some new designs. It is intent-driven. It is autonomous evolution. It has the flexible task, and so on. That is 1, 2, 3, 4, 8 big components. There are a lot of challenges in these components. But if we can achieve these goals, we can just get an object that we can just make the robot as a out-of-box usage. just like a phone. You buy the phone, and it will everyone can buy the phone, and you can just install the app what you want, and it will do the things work. And if you buy the robot just like there, just put it in there and it will be work. It will learn something. It will learn the new stage, learn what things happen in this stage, and it will do something work. Maybe clean the room, maybe do something, turn the light. That's all. So in the follow, I'll give you some technical details of our design. The first one is the intent. This is intent. This is an example of the intent. We use just some algorithm. This is the top level papers we have just published. You can just get it from the internet. And in this one, we can just see from the robot's camera, and we can just understand this picture. We know there is a person, there is a sofa, the relationship of this person and this sofa, and we get a series of this relationship, and we can just predict what will happen. What will happen? That means that what the people intend. We can say that these people will sit down on this sofa. So the robot can do something in advance. Maybe just clean up the sofa. You can just sit on this sofa. So this is the intent prediction. And we have just do it in a lot of the scenarios, for mobile phone, for another tasks. Another thing, the second thing is flexible task. This is the picture shows flexible tasks. We have a controller. The key design of this technical skills is the controller. It will monitor all the things happen in these scenarios, which we just show this picture. This video cannot be played. So if you in this picture, in this video, will show that this is the view from one camera, and if we just sit down on the chairs, there is a change in the view of this camera. That means that if the situation changes, there is a good new devices. It will work well, work more better. Yeah, so this is a flexible task, and there are a lot of the other technical design, such as the coordination, such as the semantic graph, and the semantic graph and the new skills just mimic what the peoples do. So there are a lot of the technical details. And we just show some things. And the final part of my talk is applications. There are four scenarios. There are four examples. The first example is the smartphones. This is a smartphone. The use case of the smartphone for my operating system. And I also tell you that I am the chief scientist of this big company in Chinese. And you can see it that this is the app that we have just designed for these scenarios. It is a flexible things. That means this is a travel example. During the planning, before departure, on the way, before arrival, after arrival, that this app or this service will change, will go along with you. That means that if such as this one, before departure, that your your schedule of the airport will be show like this. This is a card. That it will remind you that you need to prepare something to go to the airport. And if you on the way, these things will change, and before arrival, change again. That means that the tasks, the program will change along with your situation. This is another example. We use this operating system in the smart vehicle cabin. I'm also chief scientist for this smart vehicle cabin company. Just ignore it. This is an application example of our robot. In this video, we can see that there is a robot. It will go around just like a person. Maybe you can see it because the video cannot be played. This robot will replace the worker in this industry site. It is worked in the real world, so we have done it. And the fourth example, the last example, is the autonomous drone operations. We can this is for the light, for the solar light electrical site. That if from this site we can just make some tasks and operate the autonomous drone to operate on it. So that means that in conclusion, this is the final one. In conclusion, I will just give you some overview of my talk. That in the future, the humanoid robot will maybe go everywhere in the city, in the street, in your home, in the industry site, and it needs new operating system. The current operating system cannot work, so it needs a new operating system. This operating system needs a new design. I have given you eight different challenges and what we have done for this challenge. And we apply this operating system in the mobile phone, in the smart vehicle, in the humanoid robot, in the autonomous drones, and we have got some results. And maybe in the future, you will. I am very happy to welcome you to China, you to Shanghai, and maybe you can visit my company and look around what the humanoid robot with our operating system, innovative operating system, can work, can make this humanoid robot just like a human. They can do everything the human can do it. Thanks so much.
Thank you very much, Professor Li Zhizun. Thank you very much, and we have a few questions from our audience, and if you don't mind, I will ask them. But first, what I'm thinking about, sometimes when I ask questions from the stage, it seems not very loudly. And what I'm thinking about, if I were artificial intelligence, the level of my voice will be increased automatically.
Maybe, yeah.
So, the question from our audience is, what advantages does a unified operating system offer for robots compared to highly specialized solutions?
Okay. It is a good question. We need a unified operating system because in the current state of the humanoid robot, not a humanoid robot, just an intelligent robot, not like just a human, maybe with some wheels. There are a lot of things needed to customize this robot, including the hardware and the software. This customization makes the devices very expensive. You know that the people don't like expensive. They like cheap. So unified operating system can make the everything will be cheap and very easy to use. As you know, there is a good example for the cell phone. Android, iOS is the unified operating system. This system makes the cell phone go over the world. Everyone can use it. So it will be the trend, it will be the target of the humanoid robot, in my opinion.
Thank you very much. Thank you.
Thanks so much.
Professor Lee Ji-Zun, ваши аплодисменты.
Professor Lee Ji-Zun, thank you very much.